Okay, so welcome back, and today we're going to look at finding a representation for this function f of x, a power series representation. So we're going to do the same thing that we did in the last video. So we're going to find the derivative, find a power series representation for the derivative, and then by integrating the derivative of the power series, or this power series representation of the derivative, by integrating that term by term, we can find the power series representation for f. Okay, so again, so in this case, we know that the derivative of inverse tangent is 1 over 1 plus x squared, which again, we know we can write that as 1 over 1 minus negative x I don't want to write that. Squared, like that. Okay, so notice that the negative is outside the square. Okay, now, but again, we can write this as a power series. N equals 0 to infinity of what? It's going to be negative x squared to the nth power, right? And so what does this give us? That means that f prime of x, oops, should be a prime. So f prime of x is equal to what? Well, this is going to be 1, and then it's going to be negative x squared, and then it's going to be plus x to the fourth minus x to the sixth plus, and so on. Okay, so we're getting alternating series. Okay, now again, this is true for the absolute value of x. Again, this is convergent. This is for the absolute value of x is less than 1. Okay, again, this is convergent on the interval from -1 to 1. Okay, now what we're going to do is we're going to integrate this, right? So again, to find f of x, right, the f of x is equal to the integral of f prime of x, and we know this is the antiderivative of this, right? And so f of x, this is going to equal the integral of this, which is 1 minus x squared plus x to the fourth minus x to the sixth plus so on and so forth, right? And so when we do this integration term by term, we end up getting c plus x, oh, it's not plus, minus. No, it is plus. Plus x minus x cubed over 3 plus x to the fifth over 5 minus x to the seventh over 7 plus so on and so forth. Oops. Okay, so now, okay, so what does this look like? Well, it's an alternating series again. Okay. And we need to figure out c. Well, again, if we make c 0, first of all, let me see here. Well, yeah, we want to make c 0. And f of 0, well, when this is 0, so we want to know the tangent, the arctangent of 0. Well, so this is an angle, right? So the tangent of what angle equals 0? Well, it's 0, right? Tangent of 0 is 0. So the arctangent of 0 is 0. So c is equal to 0. So that means that f of x is going to equal x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7. And so now, well, what's going on here? Well, what is this going to equal? Well, this is going to equal the summation. It's going to be the summation of -1. And we've got x over, in this case, let me write this here as x over 1. So we've got all the odd powers and all of the odd denominators, odd integers, okay, or the odd natural numbers, if you will. So how would we match this up? So this would be, how do we do that? Oh, here. 2n plus 1 over 2n plus 1. And then this would be n, right? Would that work? And that would be from n equals 0 to infinity. So if n is 0, we get positive. This is going to be x over 1. That'll give the first one. If x is 1, we get a negative, and we get x to the 3rd over 3. And then if n is 2, we get positive, and we get 5 over 5 right there. So it looks like it works, but again, we don't want to leave it like that. Well, I guess we have no choice because I can't. Yeah, in this case, I guess we're done because we can't. Because we got the 2n. So unlike the last one, we can't really put this in terms of x to the n. So this is it. So this will work. Okay, so then this is the final answer. Oh, and the interval of convergence? Well, in this case, the interval of convergence is -1 to 1. Okay, now, again, we're going to have to check the endpoints. Okay? Now, if we look at x equals 1, then this is just going to become an alternating series of 1 over 2n plus 1. Okay, and then we can use the alternating series test, and it converges when x is equal to 1. It also converges when x is equal to -1 using the alternating series test. So you're going to find that this, using the alternating series test, is going to converge at both 1 and -1. So the interval of convergence for this series is going to be -1 comma 1. Okay, with square brackets. Okay, and that's it. Have a great day.